And for section 7.3, ratios and proportions. So ratio is actually just another word for fraction, but this is more like applications of fractions. So for example, if there was a class that has twice as many girls as boys, so it's not saying how many girls there are, and it's not saying how many boys there are, but it's describing a ratio. So in other words, for every one boy, there's 2 girls. So you could write it as a fraction, and then the ratio is 1/2 of the class is girls. Another way to write it is with this colon, so it'd be 1 to 2. So for every 1 boy, there's 2 girls. When it's written this way, it's a little bit harder to write the word in there, so usually they would say the ratio of boys to girls is 1 to 2. When you write it as a fraction, it's a little bit easier. So then proportion means when 2 ratios are equal, or in other words, when 2 fractions are equal. So if you start off with the idea that half of the class is girls, so for every 1 boy, there's 2 girls. Then what if the class had 13 boys? Then how many girls? So that right there, when you set 2 fractions equal to each other, that's a proportion. And then to figure this part out, well, since there's twice as many, you would then need to multiply this by 2. Or another way to look at it is, in order to go from 1 boy to 13 boys, you need to multiply by 13. But a rule with fractions is, if you multiply the top by something, you have to multiply the bottom by the same thing. And so then 13 times 2 is going to be 26 girls. All right, so I should label that as example number 1. Then example number 2, something that I've been doing a lot lately with the stay at home is a lot of cooking and baking. So this recipe calls for 1 cup of butter and 2.5 cups of flour. Gonna make some cookies. So then you could write it as 1 cup of butter to 2.5 cups of flour. So then, what if I triple the recipe? Can't have enough cookies. So then if you triple it, so that means multiply by 3. So then multiply by 3 on the top and multiply by 3 on the bottom. So the top one's easy. That's going to be 3 times 1. So 3 cups of butter. And then what about this one? 3 times 2.5. So one way to do it is 2.5 is 2.5 and then multiply by 3. And I know that 3/4 is worth 75 cents. So I know the number is going to be 75, but then because of this, move the decimal over by 1. So then it would be 7.5. So it takes 7.5 cups of flour, which means that I would need to go to the store, go to the aisle where the flour used to be and find it empty. Go to the next store, do the same thing, and then just realize I'm not making cookies today. Oh wait, that's a sad ending. No, I finally found flour and made lots of cookies. Now, this next example is going to be similar, but it asks the question in a slightly different way. So for example number 3, a recipe calls for 2 eggs and 1 1/4 cups of flour. And then suppose that I went to the store and I actually got a whole new bag of flour, and I'm gonna make a lot of whatever this is gonna be, pancakes. So what if I use 10 cups of flour? Then how many eggs are needed? So set up the first proportion, and the order doesn't really matter. When you make the fraction, it doesn't matter. I said eggs first, so I'm going to put that first. So for every 2 eggs, you need to use 1 1/4 cups of flour. Then make the next fraction. Now what does matter is I put eggs on top and flour on bottom. So over here, I also need to do the same, put eggs on top and flour on the bottom. And in this part, I said I'm going to use 10 cups of flour. And then what goes right here? So with the example of the boys in the class, the first example, I was able to multiply by something on the top and the bottom and get this. I multiplied by 13, I think it was. But anyway, on this one, I don't know what to multiply 1 1/4 by to get a 10. So there's a different way you can do it. So first of all, I'm going to drop the words off and just use the numbers. And for 1 1/4, I'm going to change it to 1.25. And then this fraction, since I don't know what to put there, I'll just use the letter X and then 10 cups of flour. And then you could do something that is called cross multiplying. So you multiply these two and you multiply these two and then set them equal to each other. So 1.25x equals 2 times 10. Or 1.25x equals 20. Then, in order to solve for x, what we need to do is divide by 1.25. And so x is going to equal 20 divided by 1.25. Which is 16. And I should label the answer 16 eggs. All right. Then on to example number 4. So for this information, I just went on to Zillow and I put in 93901 and I looked at a couple of houses. House number 1 sold for, it was $746,000. And the property taxes, this was actually last year, 2019, so how much they actually paid in property taxes. It was $6,847. And then house 2 sold for $430,000. And their 2019 property taxes They paid $55.85. So the question is, are these proportional? In other words, are they paying the same tax rate as they are paying? So the question is, if you take 6847 divided by the 746,000, then it's a question. Does that equal the ratio that house number 2 is paying? 5585 divided by $430,000. And for that, I definitely want to use a calculator. 6847 divided by $746,000 is 0.009. So that means they're paying almost 1%, because if you multiply by 100, that would be 0.9. So they're paying 0.9%. And then does that equal a 5585 divided by 430,000? I'm sure I have the right number of zeros. And then that equals 0.013. So these people are paying 1.3% in property tax. These people are paying 0.9. So the answer is no, they are not the same. So sales tax, everybody pays the same sales tax, but property tax, because some houses could be older in Proposition 13 many years ago, different houses have different property tax. So the answer is no. These people, which actually have a less expensive house, they're paying a higher tax rate. Then for example number 5. So at some particular school that I'm just making up in my head, 9 of every 15 students, so that's describing a ratio, they get a hot lunch. I guess the other kids bring their lunch. So then, what if the school had 400 students? So if the school has 400 students in total, then the people that work in the cafeteria need to know, how many hot lunches do we need to make? So first of all, set up the first ratio. So 9 get hot lunch out of every 15 total students. And then how many get hot lunch if there's 400 total students? And then once you have that set up, you can do the cross multiply. So there's going to be 15 times x, and then 9 times 400. So on the right side, I know that 9 times 4 is 36. So this is 3600. And then the last step is to solve for x, divide both sides by 15. So 3600 divided by 15 is 240. And then because it's a word problem, you should label it. That's how many hot lunches. All right, Now we're almost done, but I looked at the homework and there's two more that I should do that are similar to homework problems. So for example number 6. So the other day before yesterday, I ran 16 miles in 2 hours, 20 minutes. Now, it wasn't that long ago when I'd run 16 miles in just 2 hours, but now I'm 51 years old, so it takes me an extra 20 minutes. Anyway, enough about me. So, assuming that I didn't fall down and sprain my ankle or something like that, how long would it take me to run 20 miles? Well, this question is very similar to the last one. It's going to be a proportion and we do cross multiply. What's different here is this has a mixture of hours and minutes. So you either need to change this completely to minutes or completely to hours. I'm going to go with minutes. So first of all, 2 hours. So there's 60 minutes in every hour. So if you multiply that by 2, that's 120 minutes. So in other words, my time, when you change it to minutes, would be 120 plus 20. So that is 140 minutes. Okay, now we're ready to do the proportion. So this is going to be miles, which means this needs to be miles. This is going to be minutes, so that means this needs to be minutes. So the first part was 16 miles, and that is 140 minutes. And then what if it's 20 miles, and then how many minutes? So use X there. And then cross multiply and cross multiply. So one side would be 16 times X, and the other side would be 20 times 140. And then one last step to solve for X, divide both sides by 16. And then that is going to be 20 times 140 gets divided by 16. So that would be 175 minutes. So if you subtract off 120 minutes, or in other words, subtract off 2 hours, then it still leaves 55 minutes. So since the original problem had hours and minutes, then my answer should be the same in hours and minutes. So this would be 2 hours and 55 minutes. So just under 3 hours. And one last one that is similar to the homework. So this is not a word problem, but just a proportion. When this is number 7. So solve, and it's a 3x over 4 equals a 12 minus x over 6. So the proportion is already set up for us, so cross multiply and cross multiply. So one part would say 6 times 3x, that's 18x. The other one would say 4 times 12 minus x. And then over here, I could distribute. So the 18x stays on the left side, and then on the right side, 4 times 12 is 48, and then minus 4 times x. Then we only have 2 more steps. One would be add 4x to both sides to collect all of the x's together. So now on the left side, there's 22x, and then it equals 48. Then all we need to do is divide by 22. And then reduce. So this could be divided by 2 and this could be divided by 2. So if you divide 48 by 2, that's going to be 24. And a 22, if you divide by 2, that's going to be an 11. So on the other ones, I used the calculator, and sometimes, did I get a decimal answer? Yeah, like with the houses, I got a decimal answer. But in here, they're not using any decimals, they're using fractions. So my answer should just use fractions. All right, now we're done.